Hi, I'm Johannes. I'll be talking about instrument I'll be giving the talk instrument to remove using Java agents for fun and profit. I did this a while back and now I'm giving it again here at Worksday. Thanks for Worksdays for having me. It's a real pleasure to be at my first Worksday. So, as an introductory example, I want you to consider that you're a frame builder. So you come at you come into people's homes and they tell you, here's an image. I want this image to be framed. For example, to build such a custom frame and to hang it up because they want it. I know they have like a Picasso at home or something and they want a specific frame for it and they don't want the image leave the house. So what do you do? If you're a software developer, of course, you're a software developer, so you probably need some kind of power tool. So take your whole box of power tools with you. You also probably need a nail and some wood. So you take all your wood supplies with you that you have at home, and you need some nails. So you get all your nail supplies, and you probably also need a screw. So hey, just take a couple of hundred of them with me. You also need some other tools because you need a hammer. So of course you're taking all your workshop with you because in your workshop there's surely somewhere a hammer and you might need it, and probably also some other tools that you might need. And if you're a true software developer, you're just going to Jumbo and put Jumbo on a trailer and pull it with you. And if that sounds funny, that's essentially how software developers build software. So they take everything with them because they need a small, tiny thing to work with. So we always, so many of us, we were probably some of you from the Java world, me too, and we joke about the Node.js folks with the left pad, and they like have a dependency for everything, like left pad. But if we're honest, we Java people, we aren't so different. So when you look at a normal normal Spring application, here's the Spring Pet Clinic example. We also use like a lot of libraries. So yesterday, downloaded like a clean build of the pet clinic with all dependencies, and it took like 5 to 10 minutes to just download all the dependencies that the Spring framework has, and it resulted in like surely 100 megabytes with the testing code included, and the resulting jar was like 50 megabytes large, and this was just like a tiny Spring Pet Clinic that has like a couple of features, and your application might be larger too, and that's like a problem because we probably think, do we need all these dependencies? Surely not. And for example, many people they include like the Apache libraries, the Apache Commons libraries, because they just need a couple of functions, and that's pretty wasteful because nowadays it costs quite a lot of money to have wasteful memory usage in the cloud because it's loaded. So that's not great. Essentially, to quote Geek and Poke, thank God, not everything is software. So essentially, if software developers were building like towers, they would start with an Eiffel Tower and be like, oh, that looks nice, but maybe put a clock on it, and yeah, maybe put another building on top because we know that the Eiffel Tower looks nice, it works nice, so just put another layer on top, and in the end, we have like the Eye of London on top of it because we can. And that's not great. To quote Sotoro Valero, in his paper, he wrote, software systems have a natural tendency to grow in size and complexity over time. A part of this growth comes with new features or bug fixes, while another part is due to useless code that accumulates over time. The problem of safely deploying real-world applications remains a long-standing software engineering endeavor today. And that's probably why I'm talking to you today, because you in the audience are probably slightly interested what you can do about it. So how do we deploy it? So there are essentially a few types of deploying tools. There are dynamic tools and there are static tools. So with static tools, we have tools that are based on code analysis or dependency analysis. The idea is essentially that we either analyze the dependencies, like we can tell Gradle, please throw out every dependency that you don't need, or we can do code analysis, so we can select, statically, this code is probably not needed. And a good thing that we do is that we nowadays have with GraalVM, especially with native image, they want to see which parts aren't used, because with native image, pre-compiling all these 50 megabytes in your pipe-cleaning jar takes quite a long time. The main problem with static analysis is that many applications use reflection, and with reflection, all bets are off. When you have one class for name, and then just put a string that your code analysis can't reason about, this could like load every class in your whole applications. And I know this a bit because I tried to do a PhD in this field for like 2.5 years, and I can tell you reflection is a total mess. If you have one piece of reflection in your code analysis will be like, yay, that's fine. See you tomorrow, and probably don't call me again. That's even why some code coverage tools, like when you want to have really precise information, even just work on like Java 1.5, because that was the nice time before generics and all. Um, so these tools have problems, and they're of course dynamic tools. So what you can do is use coverage tools to essentially run while you're testing and see which code is taken, and you can do profiling. So essentially profiling is statistics sampling. So you ask your JVM regularly, like every 10 milliseconds, what are you currently executing, and thereby you get a glance on which parts of the software are actually used. All of these approaches have pros and cons. The code analysis you can do beforehand. It's independent of what you're actually executing, which is nice because it means that when someone comes in with a test case, with some usage case that you haven't considered in your testing, when you have an error case that normally didn't occur in your testing, you're still covered because the code analysis can guarantee you that all code that might be used is actually included. But with dynamic tools, you have the advantage that you usually get far smaller jars. Of course, with the probability of it crashing. Who am I to talk to you about this? I'm Johannes Bechberger. As I said, I tried to work on code analysis a while back, and now I work at SAP. I work at this lovely company. We produce the submachine. It's one of the many cool open source projects of SAP. We're the third biggest contributor to the OpenJDK. That's essentially what runs most of your Java applications, which is quite cool. And I have stickers for this mixer, for this cool JVM. So grab a few if you like. What I do when I don't stand on stages and talk in front of people about topics that I care about, I'm usually working on profiling front ends. I'm working on profiles like async profiles. Nowadays, I'm also working on making JFR like a profiling solution better, and got some work into eBPF just for fun. So this whole endeavor for me to look into Java agents and to look into how to improve how to develop tools for deploying started when I was in London giving my first talk, and someone saw my blog post from internally from SAP. They were like at SAP Research, and they were like, "Hey, I saw you write Java agents. Can you help us with your knowledge?" And he sent me the paper, coverage-based deploying for Java bytecode, just essentially like a coverage-based approach. But the main problem is that takes quite a long time, so it's quite expensive. And he told me like, "Hey, do you have any thoughts about this?" And I was like, slightly nerd sniped. If you don't know the term nerd sniping, it's from this XKD comic, where essentially two people sit across the street, and the one tells him, "Hey, nerd sniping, that's how you do it. There's a physicist," and he tells him a difficult problem, and the physicist that's in the middle of the road gets hit by a truck, and that's like nerd sniping. You just give nerds an interesting problem, they stop what they're doing, and yeah, that happened to me twice for this talk. So I can show you later another instance of nerd sniping for me that just happened like a week ago. So this is like the second part. In the first part, we were talking about deploying, because existing tools have problems. The main problem is they are slow and they're quite complex, and it's hard to understand them. And the main problem is, you probably also know them, when the code that tests your code gets too complex, you have to code code that tests your tester, and yeah, it's turtles all the way down. So I thought I can write my own, because that's what I do. And I asked my boss, and he was like, "Yeah, fine, do this." And I was like, "Yay." Uh, And it's more proof of concept. So all that I tell you here about is just ideas how to do this, and how to show you that Java agents and writing them can be really great, and can be really good for your team too. And I wrote a blog post on this called "Instrumenting Java Code to Find and Handle Unused Classes" as a proof of concept. So in the beginning, I want to reduce the problem, because yes, I could do like a whole academic paper on this and could do coverage based on this thing, but I'm time constrained. I usually work on other stuff. So I thought, maybe it's enough to find unused classes. Maybe unused methods, it's nice, but it's low chronology, and I expect when I remove classes, when I remove just single methods, there's the possibility that another method calls this method. So I'm looking at class boundaries, because if a class isn't used at all, it's probable that nothing else is used of, and that this class is really nowhere used. But with methods, especially because you have like error handling in methods that call other methods, it might be probable that other methods in the same class are used. So essentially, I took this class graph and thought like, hey, let's find unused classes. But how do I know that a class is unused? Essentially, I can inverse the problem. So how do I know that a class is used? So any ideas here? Do you any, can we modify this code so that we can see every time the class is used? Any ideas? How can we modify this code? Yes, a static initializer. Thank you. And that's essentially what I did. So I just, in a small prototype, I just wrote like a store that's essentially where we store this information, and it processes the class usage of the class A. And that's nice. So the question is now, when are static initializers called? And I'm like an OpenJDK nerd. I work on OpenJDK, so one of my first resources is, of course, the Java language specification. It's a great read for an afternoon with lots of red wine, because it takes quite a long time, and I usually only read it in small passages. But essentially, what it tells us, static initializer is called when T is a class and an instance of this. And when A is in class, an instance of A is created. That's nice. Also, when a static method is called, is invoked, or when a static field is accessed, or when a static field that is declared, when it's designed or non-constant static field is used. It's nice, but there's a problem with interfaces. The problem is here that this is forbidden in Java. It's not forbidden in the bytecode, which is interesting, but it's forbidden in the Java in Java, which is not that great. It might be also forbidden in bytecode, but I have to check again in the JVMLS. So essentially that's a problem. But yeah, you see, it's allowed in bytecode apparently, according to my slides. I learned something new today. I hope you too. This is just, we can edit and can like handle interfaces separately, but that's fine. You can just write code with it. So the idea is that in the end we have like our classes, and the green are like the recorded classes that we found, and there are of course two types. We have classes that are used, and classes used and loaded that we saw before in Java. And we have dynamically created classes. We have them, for example, for lambdas and such, or for tools like ByteBuddy that you use with Mockito and Spring, that also create classes dynamically. But we don't care with the bloating about them, because we can't prevent their creation. Of course, we could use something like Quarkus or so that don't create classes at runtime, especially when you use native image for it. But for our purpose here, we were looking into normal Java applications. And then we have like all of your classes that are loaded, and essentially we see then that the intersection of like the recorded classes and the loaded classes are these classes that we will need, and the other classes are bloat classes. But what do we need? What do we do with this information? So essentially, an idea is to remove the bloat classes. So that's one approach, and that's cool. But the main problem is, our application could crash, and if we're not totally sure that we really want to, that can remove them, we probably shouldn't. Of course, we can. We're now in the age of microservices, so of course, what we could do, we could just run it, and when it crashes, we just restart the whole thing with our legacy application that is not deep loaded, and that's fine. But another thing with deep loading is also that it prevents us from security issues, because essentially, when we remove a class, or when we prevent a class to be executed, we don't have to care about the security issues in this class, which is pretty neat. And we essentially reduce the attack surface and also have some reduction of supply chain risks in there. And another idea is, so for this, how to implement it when we don't remove it, we just log an error, and maybe we even like throw an exception, but it's probably enough to log an error and be like, oh, this class that I thought I wouldn't use is used at all, and yeah, maybe write this down somewhere and then someone can look at it, like maybe like a security incident, I don't know. Now for something completely different. Yeah, essentially implementation time, yay! That's what you're all excited about. Hopefully, it's about the implementation, and in come the Java agent. So, what is a Java agent? I like to write in bike. So essentially, a Java agent is nothing more like a bike computer. Bike computer is a tool that you can use to analyze the performance of you and your bike, and essentially you attach this to your bike. There are also bikes where the bike computer is integrated directly in your bike, for example, for e-bikes, but normally you attach it to it. It observes information, for example, your speed, your cadence, and you can use this information to make decisions. And so essentially what an agent is, we attach it to our JVM, and when we attached it, it runs inside the JVM. And side remark, the problem is when it runs in your JVM, it also runs like in your agent's classes can clash with the JVM's classes, and you might have some problems. So you have to be sure to shadow your class, to shade your classes in your engine so they don't clash with your JVM. This happened to me yesterday when I tried one example out that I haven't tried before. So yes, be aware that running agents, they run in the same process, so they have some problems. Of course, you can always use native agents. These are not written in Java, but these are commonly used. For example, your debugging, when you're doing debugging with JWP, the JWP agent is written in C++ and is a native agent, and you can also touch it. There's the possibility to use other methods, but usually Java agents are written in Java and can do a couple of nice things. For example, instrumenting, because in the end, we don't want to add our static initializers in every method ourselves or write some random code instructor that like goes through the bytecode at compiler, but you usually want to instrument directly. So the idea is here that there are two ways. So we can either run our JVM with an agent, and then we get a use class, essentially writes it down, and then we get it. Then we put it back in there in our instrument, and either run our instrumenter directly on the jar and remove classes and modify it, because with Spring, sadly, we have to instrument the jar beforehand, because Spring doesn't work that well apparently with instrumenters, but we can use the same methods that we use in the Java agent, and then we get a reduced jar or jar with error messages. Yeah, and that's kind of how it works, and that's pretty cool. And yeah, Spring does a lot of magic. Spring does a lot of magic. This is why we have to pre-instrument the code. But yeah, as I said, it used the same logic as before. And that's it's a working agent. You can try it out. I've put a QR code here, so if you want to try it out, it's of course a prototype, but gives you insights of which classes are used. For example, for my pet clinic application, for a Spring Pet Clinic application, I had a jar of 56 megabytes, and I run this and saw then that like just of the 30,000 or so classes, only 12,000 were actually loaded at runtime. I clicked a bit around in like the Spring Pickling, and of these, only 9,000 were actually used and being used in a manner that I told you before, like the aesthetic initializer was called, um, which is pretty interesting. So we could have probably reduced the size drastically of this jar with my application. Especially because we can tell my code also to just remove like the loaded classes, just remove the not loaded classes. It also helps. So what's the structure? So an agent consists normally in three parts, and that's the same for most of the agents that you write. So you have your main method that contains an entry point, and then this main method does the command line parsing, does like the argument parsing and such, and starts usually some thread, because your agent, when it runs and runs and runs, in its normal thread, it halts the JVM, which is not great. So we start a new thread and mark it usually as a daemon, so that the JVM doesn't have to wait till this thread stops to stop properly. And so here in our case, it's the class transformator. This is just a simple method called transform that transforms our code. And then we have a store, and essentially we have to store our information somewhere. Here in our example, we store the loaded and use classes, and to get to the information that you saw before. But with a slight problem. The problem is, and maybe some of you have an idea, we want to add code like the store get instant whatever. So we want to access the store class from our code. Anyone has an idea what the problem here is if we just like modify the code and insert it here, and if store is part of our agent? Any ideas? Okay. The problem is with class loaders. So the main problem is here that you all hopefully are familiar with class loaders. For those of you who are not, it's essentially where the Java loads classes, and there's a hierarchy. So if your class loader doesn't know where it finds it, doesn't have this class, it asks this parent class loader, hey, do you have a clue? And so we have typically the bootstrap class loader, that's like the bottom, that's like the top layer. It's the class loader that every other class loader falls back to, contains some really basic classes. Then you have your platform classes that contain things like your java.sql, your javax.sql, your sun security, whatever. It just contains like miscellaneous stuff, while your bootstrap class probably contains like java util or such. And then you have your application, and your application is also, class loader is also known as the system class loader, and that's essentially the basic class loader for your application. And then you have typically, when you load from different jars, you have also different class loaders here. The thing is, it's quite, you can, from the app class loader, of course, you can, when you have a class there, you can use a class from the bootstrap class loader, but the other way isn't possible, because in the other way, when we, for example, have a class in Bootstrap or in Platform, and it tries to use your class that's in the application class loader, it can't access this class, because it asks this class loader, hey, can I get this class? And the class loader is like, which class? So that's the problem, and there's a simple solution for this. Essentially, we package part of our code into a separate jar, usually called a runtime jar. So our agent essentially consists of like our agent and the runtime jar, and we insert this runtime jar into the bootstrap class loader, which an agent can do. And that's real nice, because then every class can use our store class, and this makes instrumenting far easier. But this also normally means that that your agent jar contains in its resources folder another jar, the runtime jar, and then unpacks the runtime jar from the resources to load it in. It's some logic that almost every Java agent needs. But you code it once, and then you probably heard it in the keynote, and then we use the good old copy paste technique for this. I'll show later how I typically go on designing Java agents. So yeah, and then it breaks. That's nice. I wrote a blog post on this because it bothered me so much. So this was one they probably wrote in the train riding from Milan to Zurich. We had the pleasure to be with Jug Milano. If you are in Milan, just go there. They're nice people. Um, and so the question is now, how do we implement the transformation? And so, um, how do we implement? How do we implement this appending to Bootstrap? Essentially, every agent gets an instance of the instrumentation class. Um, and this has a method called append to bootstrap, and just append it to it, and that's quite nice. And we just call it, and that's fine. And that works. And so how do we start then our agent? Because we now know that we probably have to attach something to our bootstrap methods, but how do we actually start it? And normally when we're in Java, we start our applications with an entry point and we start them via the main method. And many of you probably don't know, but in all Java versions, there's also the second variant where we can put the brackets behind the args. I think it's a relic from the old C times, but you can still write it. You can try maybe in the code review. That's a way to see whether your code is actually reviewed by your colleagues. I did it once. It's quite nice. And nowadays, I think it came with JK21. You can also just write the main method down below, but that doesn't help us because the main problem here with agent is we can either attach them at a JVM start, so we can pass it as an agent on the command line, or we can attach it later. So when we attach it later, the method agent main is called, and otherwise the method pre-main is called. They come in the variant of like having just the agent args, which is a string that you pass for the arguments, or they get parsed the instrumentation class. And the instrumentation class gives you, as I told you before, like access to append to bootstrap, but also to methods to add class file transformers. So that's essentially what we do. We add a new transformer, as you see in the last line here, and we also have to tell that yes, we want the transformer to be able to retransform classes, so to transform them after they've been transformed before. So when we look into the documentation, essentially the idea is with these class transformers that an agent registers an implementation of this interface using the add transformer method, so that the transformer's transform method is invoked when a class are loaded, redefined, or retransformed. That's quite nice. It gets some parameters, and essentially what we do, we check, hey, is this a class that we want to deal with? We usually don't want to deal with classes or instrument classes that are in the Java runtime library anyway, or our own classes, because we get them in endless loops and endless recursion. But how to actually transform the bytecode? There are a few libraries, a few nice ones. For example, there's javassist. It's a thing from the JBoss ecosystem, and that's what I typically use because I'm used to. But of course, there's a ghost in the room. There's of course ByteBuddy here, Raphael Winterthaler. It's also a great library. It's used, for example, by Mockito. So the idea here is then essentially what we do. We can use our javassist library in some setup code, but essentially what we do, we just create a class initializer, and we tell it here that's the code that we want to do, as you saw before, like the store.get instance process class futures method, and that's essentially all. It passes this code, transforms it to bytecode. Yes, you could use the asm library and do it yourself, but it's such a mess, and I tried it. It works sometimes, and you have lots of fun debugging, so usually just use ready-made libraries. With Spring Pet Clinic, we can just call our byte-code agent. We tell it where to output the loaded and used classes, and then it outputs us, for example, that the class pattern layout encoder is used and the class drawer and configurator is only loaded. Yeah, that's all. We can use this information then, and if we didn't properly test our application while like running, and then we later use methods that weren't in the set. Um, it tells us, hey, this class is used, but I didn't find it before. That's nice. I think I have still 5 minutes left. Hopefully. Good. Oh, good. And I still have time for the nice good part that I wrote yesterday in the train. So who of you has wrote an agent before? There's not so many. Write more agents. I do them every week. An agent a day keeps the debugger away. I don't know. So um, there are like other applications of agents, of course, and there, for example, I just glanced shortly after it over it, there's the possibility to write your own profiler. I've given this talk too many times to count. You can just look it up in your favorite video streaming platform. I wrote something about it. So essentially, you can write a Java agent that profiles the application. It's approximately 204 lines of Java code, and it's a fully functional profiler, which is nice. And it's probably used by some bank in Milan because somebody told me this. So when you write open source code, be sure that it's someone else told me like he's using it for VMware profiling because whatever. When you put things on the internet, people might use it, especially I'm coding mostly in open source. But yeah, you can do it. The problem is now who instruments the instrumenter and why should we do it? The main problem is, consider, I hope it's readable, consider you have the Mockito library. It's a well-used library, but the problem is it also uses bytecode transformation. So for example, here, the essential bit is that I mock here the mock list, mock here the list class. And so what this uses, it uses byte. And so what does this do? So what we can see with some magic tool, it essentially instruments a few classes that it instruments the list interface and all interfaces up. So all methods are instrumented there. For example, also the iterable method. And then I got nerd sniped again because that's what I do, get at work. So somebody called me after a conference when I was in Canada 2 weeks ago, told me like, I want to debug problems. I saw a problem in Mockito. And I want to see what is the actual transform bytecode. And I was like, that sounds like an interesting problem. And because essentially, oh yeah, that's an interesting problem. So I thought, hey, I can do this. And it took a little bit longer, but I had a flight home from Montreal, so I had some time on my hands. But how do I design an agent? So what I typically do, and don't do this in any other software project, just works because agents are typically small. They're typically just a couple of 100 lines of code. If they get larger, use typical software architecture, use the software design process. But usually what I do with small agents, they just solve a single specific problem. I choose a few prior agents. In my case, these agents were these were my dependencies agent that I showed before, and some other agent, and they just copy the code in. And that's fine, and then I just replace the code transformer, and that's essentially all, and maybe replace the store class. But essentially, it's just copy pasta. It's okay, as I said, it's just a couple of 100 lines of code, but don't judge me by the quality of the code of my agent. Usually you also find like HTML code interspersed in. The main problem is I don't want to pull in too much code because I have to attach them to my applications. And then I test and debug, and testing and debugging takes like more time than all the rest above. That's fine. So essentially what we can use this tool for, so you have this, for example, this simple method in the collection interface that's just stream. And normally stream just calls stream support.stream, and but what it does when we use Mockito, it does quite a lot more. And the cool thing is, with my tool that I developed, it's easy to debug this, and I promise you I didn't just do this. I promise you I didn't just do this to say these words, but yes, it's an instrumenting agent for instrumenting agents, and I like it. It sounds nice. So essentially, the idea is here that you saw this add transformer method before. Essentially, I'm instrumenting the add transformer method, so that whenever someone adds a class file transformer, I'm wrapping this class file transformer in something else and doing this, like checking all methods, all constructors, and replacing this. And that's pretty nice because in the end, my agent opens opens the port. You can attach this agent. It opens the port, default in 7071, and you can see all the class file transformers that transform stuff, and you get a diff before and after. So you can see here that how one class was transformed by the Mockito transformer, which is nice, and you can see get all the current bytecode of classes, and it's really helpful. And I'm currently working with Michael, someone that I met in Quebec, and he's currently looking into um, problems in Mockito. So he's trying to fix bugs there and maybe get some optimizations there. So if you ever want to debug your instrumenting agent, use my instrumenting agent for instrumenting agent. And you can find a link up there. I'm currently fixing up this tool, and it soon also allows you to see diffs of bytecode directly, but essentially that's a decompiled version of the bytecode there using the IntelliJ decompiler. That helps you really when doing debugging work on instrumentals, because otherwise it's pretty hard. You can find the tool above. It's my meta agent. And thanks for coming with me on this journey to seeing the Java agents. Are quite fun. I hope the next time I give the talk, more people will be, yes, I wrote an agent. Hopefully a few of them are like, I wrote one every week just to come into practice. So I was Johannes Bechberger. You find me on Twitter as Nerd and on Mastodon. Also, I blog every 2 weeks on stuff like eBPF, profiling, debugging on my blog at mostly_nerdless.de. My team is at Sweet Submachine, and you can find our team also at submachine.io. It's one of the best JVMs out there. I can really recommend. And yeah, I have stickers. Yay. It was nice talking to you. Thank you.
Any question? Okay, so I have a question actually. You said that you can attach an agent when the JVM starts or
Yes.
after when it's
Yes.
already running, but I believe they are deprecating these second options, right?
Oh yes, no, yeah, oh no, yes. This debate. There's a debate on the mailing list to maybe deprecate attaching them dynamically. So in future versions, you get I think starting with JDK22 or JDK21, you get a warning if you dynamically attach an agent after start. And some people hate that you can attach it after start, but let's see. Because many profile and debugger developers want to attach them after start, so let's see whether it will be removed. I think there are many people against it and only a few towards it, but it's like also kind of a political debate. Yeah, let's see. That's
Well, I think there are also, security reason for not allowing this
There are kind of security reasons to attach later, but essentially, if you can attach an agent later, then you have full capability to do anything on your system. So I don't.
yeah.
When you can do remote code execution, then it's too late. Then you can do everything. Then you can like get all the passwords, leak your database. So I think it's based on this deprecation is based on faulty assumptions. There's some mail threads out there. If you're interested, just write me a text and I can send you these mail threads. But I think the last word isn't that, and let's see what the future brings. Currently, it's still allowed.
Thanks. Other question?
Can you attach more than one Java
Of
agent
course,
to?
yes, yes,
Oh,
you can attach more than one Java agent. I even tried to do this, so I even tried to attach my instrumenter agent to my together with my that code agent. The main problem was issues with like class paths because they were overlapping, whatever. So I had some issues. You have to be careful that you don't define classes twice with the same name. So I would definitely recommend using something like shading where you rename all packages in your agent to be something unique. But yes, you can attach multiple agents. I don't know whether there's a number restriction, but the problem is the more you attach, of course, the slower your application gets. Because essentially when you add a transformer, this transformer is called whenever a class is loaded or retransformed, and if you have like 1,000 agents, this takes quite a long time. Any more questions? I don't see anything, then thank you.